So we are going to start off in your maths book with chapter 8. So chapter 8 is called The Fundamental Principle of Counting and Probability. Okay, so it sounds really complicated, but actually the maths in this is quite nice. It's nice and straightforward. It's things that you can relate to, like flipping a coin or rolling a dice or picking a card out of a deck of cards or picking a counter out of a bag or something like that. Okay, so all of this is quite some things in maths can be a little bit abstract, so a little bit kind of harder to grasp because it isn't something you can actually do with your hands. But this is. Okay, so that makes it nice. It will be different, I think, to maths that you've done in primary school, but that's okay because you're moving on a level here. So like I said, it's chapter 8 in your book. Your book always gives learning outcomes. Now, I suppose I will talk you through the learning outcomes that I want you to achieve in any particular class. The way these are labeled or explained, they're really, really wordy and really complicated, and I personally don't think this is something you should be worrying yourself about. This little blue box, however, is important. Okay, so this in the blue box is what we call prior knowledge. So it's knowledge that we hope that you have or that you would need to have before doing this chapter. Okay, so you would need to know how to work with fractions, decimals, and percentages to be able to do this chapter. Now, it's on the primary school curriculum, so you've all done work with fractions, decimals, and percentages. People tend to have mixed feelings about fractions. Fractions in particular, even though technically they're all the same thing. But anyway, I'm not going to assume that you know these things. I'm going to show you these things as best as possible, and if you are confused or struggling, you can ask. And you do remember now, unlike in primary school, you can use your calculator. So most of what I'm going to teach you in first year and hopefully all the way on through to sixth year, we sort of make a little bit of an assumption that you have now learned how to add, subtract, multiply, and divide. And we don't really test you on that anymore. We now test you on how far can we go beyond that, beyond adding and subtracting and multiplying and dividing. So for that reason, we use the calculators to do things like, a difficult multiplication. Rather than doing a long multiplication in your copy, you just do that multiplication on your calculator, because that's not what we're testing. We're not testing whether you can multiply or not. You've already learned how to do that in primary school. Now we're pushing it on a step. Okay, so I know my first years last year kind of struggled they almost saw it as a weakness having to use their calculator. And that is not the case, okay? Your calculator will be your best friend in maths, okay? So I don't want you using your calculator to add 4 and 5, because you can do that in your head. But in terms of multiplying 140 by 26, you learned how to do that kind of maths on a piece of paper in primary school. You won't be doing that now in secondary school. We assume you now know how to do that, and that kind of maths will be done in your calculator, okay? So you will adapt to using your calculator, I promise. The next thing that's important is this little box here, the yellow box, which is your keywords, okay? I would use these keywords as a study guide. So when you get to the end of this chapter, and I'm giving you an exam on this chapter, you should be able to describe, not in any kind of mathematical language, just in your own words. Like, when I say sample space, what do I mean? When I look at a systematic list, what's a systematic list? What does the probability scale look like? How is it different from the likelihood scale? So you can use your keywords as a guide to testing yourself on whether you know this chapter or not. So if you look at one of these keywords and you're like, oh my God, I have no idea what a relative frequency is, then you need to go and study relative frequency. Okay? So the keywords are very, very important. You need, by the time you finish this chapter, you need to be able to look back at those, Look at the word outcome and go, I know what an outcome is. Look at sample space and go, I know what a sample space is, and I also know how to make one. What's a systematic list? Again, I know what a systematic list is, and I can also make one. And so on all the way through the chapter. So some of them will just be words and you just need to recognize the words. Some of them will actually be a bit of maths that you need to do. So a two-way table is something that you need to draw. A tree diagram is something you need to draw. So as well as knowing what is a tree diagram, you need to be able to draw it, and you also need to know when would I use a tree diagram. So this is a brilliant guide to whether you know that chapter or not. You're going to do a lot of work this year on what's called self-reflection. So that's when you test your knowledge. So you go off, I tell you you have a test, you go off, you study a chapter and you decide whether you know it well enough or not. You come back, you do my test, and you assess how well you did. So you're almost trying to guess what mark you got type of thing. So you'll get very good at self-reflecting. And when we do it the first time, so when I give you your first exam, I'll help you do this. We'll study together, I suppose, for the first exam. Okay, but all I want you to know is that the yellow box is really, really important. It contains the keywords, and the keywords is how you study. Okay, it's your guide to studying the chapter, to revision. All right, so let's get started. So like I said, it's chapter 8, it's the fundamental principle of counting, and the first thing we're going to do is list outcomes. Okay, now, there are 3 ways of listing outcomes, depending on the question. Okay, the first way is, I spoke about it there a minute ago, it's a systematic list. The second way is a two-way table. And the third way is a tree diagram. Now, sorry, I should pause here and say that I realize this is, online or whatever, but this is the same as my board. So you need to take notes. The advantage here is, I tend to talk at a mile a minute. At least here you can pause me and get me to shut up for 5 minutes while you write it down. But you need to take these notes down into your maths copy. Okay, so you should have a heading, chapter 8. You should have the fundamental principle of counting. You should have listing outcomes, and then you should have the writing that I have here, so that there are 3 ways of listing outcomes. Another important key word here is the word, it's not a word really, I suppose it's a phrase, sample space. Okay, a sample space is the name for the list of outcomes. So if you use this method, if you use systematic listing to create a list, the list you end up with is called a sample space. If you use this method, if you draw a two-way table to create a list, the list is a sample space. Okay, so these 3 here are methods of creating a sample space. Okay, now I'm going to keep repeating these keywords. You'll get it. Okay, but it's really important that you understand all of these things. Another thing I should say is that maths is its own language. So most of you are learning Irish, you're learning possibly French or Spanish. Maths is its own language, and you need to learn how to read it, and you need to be able to communicate using mathematical language. So you don't skip over these long words or these awkward words, or you don't say, oh, I made a bit of a list there, miss. You say, miss, I made a sample space when I was trying to get the outcomes. Okay, so you try as much as possible, and when we're back in class, I will encourage you to use these words, because the more you use them, the more familiar they'll become. And when you do exam papers, and I tend to do, so your exams starting in about 6 weeks will be from junior cert exam papers. Okay, there's no point in hiding from them. They're there, you're going to have to do them. And the language in those exams is the language of maths. Okay, so I need you to try and start using this language with me. Okay, so we have 3 different ways to essentially make a list, but that list has a special name, and the special name is that it's a sample space. Okay, so what we're going to look at today is the first 2. Okay, so you can see here I have number 1, systematic listing. Systematic listing is used for very simple experiments or examples. I don't know what the right thing to say there is. Essentially when it's normally a single thing that you're trying to list the outcomes for. So sometimes you'll be asked about like listing the outcomes for, I don't know, flipping a coin 3 times. Okay, so that's 3 different coins. That makes it complicated. Or rolling a dice twice. That's 2 dice. That makes it complicated. But when you roll the dice once or you flip the coin once, that's simple. Okay, so these single experiments where you only roll the dice once or you only flip the coin once, they're much easier to create sample spaces for. So we just use systematic listing. So, for example, a standard, when you are when you're looking at the examples here, you actually don't need to write like this bit of it. You just need to write this bit, okay? And you'll be able to then match it up to the example in your copy. Okay, so there's no need to be writing out all of this. If you just write example 8.2 and then you can put my answer down. Okay, that's just for your notes, all right? So a standard 6-sided die is thrown. List all the possible outcomes. So when you take die is the singular of dice. I always get this confused, but if you take a die and you roll it, what could you possibly land on? You could land on a 1, you could land on a 2, you could land on a 3, a 4, a 5, or a 6. Yeah? So all dice go, they're 6-sided. It says here it's 6-sided. It goes from 1 to 6. No numbers are repeated. So if you roll a dice, if you're playing a game and you roll a die, what are the possible numbers you could land on? You could get a 1, you could get a 2, you could get a 3, a 4, a 5, or a 6. So what we have created there is a sample space. So we've created a sample space using systematic listing. The word systematic there is just that your listing is in what's called a logical order. So like that, I ask you to list what you could possibly get when you roll a dice. You wouldn't go, I could get a 2, or I could get a 4, or I could get a 6. You do it in order. You'd say 1, 2, 3, 4, 5, 6. That's logical. So that's where the word systematic comes from, that when you are creating your list, you create it in some kind of a logical order. Okay, but essentially what we've done is we have listed all the possible outcomes for rolling a standard 6-sided die, and the possible outcomes are 1, 2, 3, 4, 5, and 6. So I have created a sample space. Yeah? Now this is a slightly harder example, but still makes sense, I think, to use a sample space. You could potentially use something else, but we'll stick with the sample space. So Emma is trying to decide what meal option to have at a restaurant. She has a choice. She can have pizza, chicken, or fish for her main course. And then she can choose either a juice or a water to drink. List all the possible meals that she could order. Okay, so again, we need to be systematic in this. So she could have pizza with juice. She could have pizza with water. So that's the pizza done. Next, she could have chicken with juice, or she could have chicken with water. And then the last one is fish. She could have fish with juice or fish with water. So now I have 1, 2, 3, 4, 5, 6 possible outcomes, and that is the sample space for Emma's meal. Okay, so that's a slightly more complicated example where we had to mix sort of two options, her meal and her drink. And I still created my sample space. And you can, obviously I didn't use full words, but that's fine. So you can see pizza juice, pizza water, chicken juice, chicken water, fish juice, fish water. Fish water sounds nice. And again, I did that in a logical way. I didn't just pick any meal and any drink and then move randomly on to another meal and another drink. I did it in a systematic way. I did pizza first, then I did the chickens, then I did the fish. It was very organized. So that's systematic. Okay, so systematic listing is used for reasonably simple questions where what the person is doing is quite a simple thing. So the first person was rolling a dice and the second person was just choosing a meal and a drink, and there was only a few options, so it wasn't too complicated. So systematic listing is a good method when the question is quite straightforward, and then you get your list. Another word for your list is your sample space. Okay, the second one. So the second one is a two-way table. A two-way table is used when there are two decisions, I suppose. So a two-way table would actually have worked really well for Emma here because she had two decisions to make. She had to decide her main course and she had to decide her drink. So that was two decisions. So you could definitely have used a two-way table for Emma. Okay? Now I'm going to show you how to do a two-way table. This example in black here, I've obviously written myself, so you will have to take that down. But the question is, list all the possible outcomes when a coin is flipped and a die is rolled. Okay? So let's think about the coin. What are my outcomes for a coin? If you take a coin and you flip it, what could you get? So hopefully you're telling me I could get heads or I could get tails. So they're my options. Yeah? So it doesn't really matter which one you put across the top and which one you put down the side. It makes no difference whatsoever. The coin was first, so I put it across the top. Okay, so that's across the top. Down the side then, I'm going to do my second thing. Okay, so the second thing is the dice. So when you roll a dice, what are your options? You could get a 1. You could get a 2. You could get a 3, a 4, a 5, or a 6. Okay, now that is my two-way table. Two-way because you've got something across the top and something down the side. So that's a two-way table. That's why it will only work for two things. Okay, so two decisions, I should say, or two experiments. In this case, it's an experiment. So this person, whoever it is going to flip a coin and they're going to roll dice. So that's an experiment. But again, there's two things in it. There's the coin and there's the dice. Okay, the two things could be like, I'm going to flip a coin twice. Okay, you're just looking for that two things and then it's a two-way table, right? So let's have a look. So this one here, okay, this box here is a combination of the 1 and the heads. So it's 1 and a heads. So one of the possibilities, one possible outcome when you flip a coin and roll a dice is that you could get a head on the coin and you could get a 1 on the dice. Okay, that is one possible outcome. This one here then is still on the 1 row, but now it's in tails. So it's 1 tails. Now we move down to this row. So now we're on number 2 and we're back in heads. This is in line with number 2, but now we're in tails. Then we move down and it's 3 heads, 3 tails. We go down again and it's 4 heads and 4 tails, and then 5 heads and 5 tails, and one more, 6 heads and 6 tails. Okay, so what we're talking about here now is that you can flip a coin and roll a dice and get 3 on the dice and tails on the coin, or you could get 5 on the dice and heads on the coin, or you could get 2 on the dice, and heads on the coin. These are all the possible combinations of what will land when you flip a coin and roll a dice. Yeah? So what have I created? Are you saying it? What have I created? I have created a sample space. And how many outcomes are there? There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 12 outcomes in my sample space. Yeah? So that is the first two, which is systematic listing and two-way tables. Okay, systematic listing for your more straightforward, simple, where it's normally only one thing that you have to do and you just make a list. The important thing is that you do that list in a logical way. So in my case, it went 1, 2, 3, 4, 5, 6, which is quite logical. A two-way table is then when you have two things involved. Okay, so a coin and dice. We could have done it for Emma because she had a meal and a drink. That was two things. All right, you create something. Doesn't matter, you decide. Something goes across the top and something goes down the side. So that's your two ways, one being across and two being down. And then you fill in the boxes. Okay, you fill in the boxes of what's appropriate and you've created a sample space using a two-way table. Okay, so what I'm going to get you to do, first of all in class, hopefully you've time, and then in for homework as well, is to do a couple of questions, just practicing listing, systematic listing and two-way tables. The reason I want you to hopefully do a couple in class is because if you get stuck, at least you can iron out some of your problems before you go home to try your homework. Is that okay? It's very important that everybody makes a good effort at your homework. I genuinely want to make you better at maths, but I can only make you better at maths if I can see where you're making your mistakes. So normally in pre-COVID times, when I have a classroom, my classroom is covered with making mistakes is the secret to success, and you know, if you can't make a mistake, you'll never learn. And it's so true in maths. Those people who are afraid to make mistakes never do very well in maths. Okay, so there's no such thing as a stupid question. You ask your questions. Everybody will support each other because some people will be brilliant at probability, what we're doing now, and some people will struggle with it, and then some people will be amazing at algebra and other people will struggle. So everybody will have their weak spots. Even I, like, everybody has their weak spots. So it's really important that we ask as many questions as possible. Ask, try and get it straight in your head. Make sure you're clear. So keep asking questions. And I guarantee if you have a question in your brain and it's annoying you and you want to ask it, there's at least 10 other people in the class who want to ask the same question. Okay, so I'm going to say it again. If you cannot get comfortable with making mistakes, you will never really get good at maths. Okay, you must be capable of making a mistake and kind of putting yourself out there and asking those questions that you're not sure about. They're the people who achieve in maths. Okay, so give it a go in class. If you're getting stuck, please ask. And then give your homework a good go. Okay, don't leave anything blank. Try everything. All right, good luck.